Hey guys, this is Miss Eisencraft, and I'm here to do a quick tutorial on the Delta Math Transformation Practice number 2 assignment. So you should see that title here. The first one is points reflected over an axis graphically. So I'm going to click on that. And what you're going to notice is this is just going to have points instead of shapes. It says the point V is plotted on the coordinate grid. Plot the point V prime, or the image of V, the reflection of V over the y-axis. So nice thing, the x and y-axis are labeled. So if you reflect over the y-axis, you're reflecting over this line. So instead of V being over here, the image of V, or V prime, will be over here, same distance. Okay, and then down below, it says, what are the coordinates of V? Well, the original V was at -6, -4, and the coordinates of V prime, or the image of V, is 6, +6, -4. So what they want you to do is they want you to sort of generalize here and see a pattern and say, okay, when a point is reflected over the y-axis, what happened? Well, this stayed the same. The y-coordinate stayed the same, but the x-coordinate changes a sign. So there you go. I'm sure. Yay, I got it right. Okay. And then it kind of walks you through that. All right, let's try another one. It looks like there is 10 of these assigned. The next one says the point S is plotted on the coordinate grid below. Plot the point S prime, the reflection of S, over the x-axis. So the x-axis is the horizontal line right here. So if we reflected it over, instead of being 3 above, it would be now 3 below. Okay, so S is at -6. The original S was at -6, 3. The new S, or S prime, is at -6, -3. So this time the X value stayed, but the Y value changed its sign. Submit. There you go. So lots of these just sort of to determine the pattern. Okay. Now, if we go to the next 5, rotate figure about the origin, this is a really good one to look at visually with rotations because they can be the most frustrating. So again, this is just exploration. So don't get too frustrated if you're getting them wrong. It's mainly for exploration and to sort of visually see what's happening when you rotate something on the coordinate plane. So the first set of directions say, we want to rotate this 90 degrees clockwise. So the nice thing about the coordinate plane is it's in 4 quadrants. And you can think of, if you rotate something 90 degrees, it will go to the next quadrant. Think of every quadrant as 90 degrees. So we know it's going to go over here somewhere. It's very hard for me to visually see rotations. So we're going to use this technology to help us. So first thing, it says draw a circle centered at the center of rotation such that one of the vertices of the figure is on the circle. So you're going to go to the origin. You're going to click, hold down, and when you drag out, it's going to draw a circle. And you want the edge of the circle, or a point on the circle, to intersect with one of the vertices. It does not matter which one. Now this is where it gets a little weird. Okay. It says click and drag to draw a line through the yellow center and the vertex on the circle. Okay. So they want you to click the origin and then match it up with the vertex that you had intersect with the circle. Okay. Now they want you to draw a perpendicular line, so one that would make a 90-degree angle. Sometimes you can get lucky and eyeball it, and then other times it gives you this weird message. So what I'm going to show you is to make a perfect perpendicular line. Just all you have to do is do a simple ratio count. So from the origin, To get from the origin to this point, it looks like you go down 3 and over 2. So if we think of slope, that's negative 3 over 2. Sorry about the handwriting. And so to make a 90-degree line, the cool thing is you just flip this upside down, the reciprocal, and make it the opposite. So instead of negative, it will now be positive. So if we go up 2 and over 3 from the origin, we're going to make a perfectly perpendicular line. Now when I hit close, that's going to go away, so I need to remember this. Up 2 over 3. Okay, so that's perfectly perpendicular. Now I have this nice grid, a circular grid that can help me see my rotation. So I'm going to go 90 degrees clockwise. The way the clock goes is this way. 90 degrees, I have to grab the red dot. 90 degrees is going to go from this line, boom, to here. Okay. Right, you can keep watching that. So good for your brain. Again. Okay, so then, we're really not worried too much about what the points do because it does get a little bit complicated, but there are some patterns you might start to notice. You do not have to have these memorized, and they're right here in front of you. So it's saying at the pre-image or the original point 4, -5, where did that go? If you watch it again, watching that point, it goes to -5, -4. And you might start to notice with this particular rotation of 90 degrees clockwise that there might be a pattern that all of them follow. So let's do the next one. 2, -8. Where does that go? So we're watching this guy. -8, -2. So what you're going to do is you're going to either watch all of those or discover the pattern, fill this all in, and it is okay to get them wrong and it's just really an exploration. But be patient and with yourself and just keep watching and have fun. It also on some of these will ask you, let me do a next problem. Give up. Yes, I want to give up and try another problem. Some will ask about a 180-degree rotation, others will ask about a 270. And I just want to remind everybody that from wherever you are, if you think of a circle, okay, wherever your circle is, right, because you're drawing it oriented different ways, every one of these jumps is 90 degrees, and you can start anywhere and then go any direction. But if we went this way counterclockwise and we called this 0, oh boy. Okie dokie. 0. And this 90, this 180, oh boy, oh no, Miss Eisencraft, and this 270, and the full rotation 360. So anyway, just reminding you that if you're like, what's 270? 270 is, 3/4 of a turn. So just remember that 180 degrees is going 90 degrees twice or half a full rotation. And you could go either way. All right. So last thing, I'll show this last one, the confusing part again, is when you first draw the circle, when you click on the center, the origin, and pull it out to draw the circle, you can have the circle intersect any one of the vertices. So if I have this yellow dot, and it matched right up, okay? So the easy part is to draw the line that goes from the origin, which is our center of rotation, to one of the vertices. But the perpendicular line, we're using a little bit of math. So like on this one, I noticed that from the origin to this point goes up 2 and over 4, up 2 over 4. So I'm going to flip that upside down and make it negative. So that would be down 4 and over 2 from the origin. So to make a perpendicular line or a perpendicular slope, you just make it the opposite reciprocal. So I have to remember that down 4/2. 1, 2, 3, 4/2, and it should look like 90 degrees. Okay, now 180 degrees clockwise, the clock turns to the right. You grab the red dot. And some of these rotations, you're going to notice that the patterns with the coordinates are a little bit simpler. Okay, and if you lose track of which point went to which, just hit animate rotation and again, and just watch the point and see where it lands. All right, good luck.